Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. When you take an exam on sequences and series, you're usually given the numbers outright. You see an obvious list like 3, 7, 11, or you're flat out told that the common ratio is 2. But the real world doesn't hand you neatly packaged variables. If you're analyzing a salary package with annual raises, or tracking the rebound height of a bouncing ball, or calculating how a stadium's seating rows expand, the math is hidden behind a text. Today, we're learning how to read between the lines, translate word problems into precise equations, and identify exactly when to use a sequence versus a series. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. So before we touch any math, your number one job when reading a word problem is to answer two specific questions. The first one is it arithmetic or geometric? If values change by a fixed added amount, then it's arithmetic. If they change by a percentage or a multiplier, then it's geometric. And once you determine that, the second question is it a single snapshot or an accumulation? If you're looking for the value at one specific step, then you need the sequence formula. But if you need the cumulative total of everything up to that point, then you need a series formula. So let's take a look at that in action through our first example. Here, we are told that a software engineer accepts a job where the starting salary is $70,000 in year 1, and the guaranteed annual raise is $3,500 each following year. The first question is, what will their salary be in year 10? So first of all, the guaranteed annual raise is a flat number of $3,500. So that tells us this is an arithmetic sequence, because we're adding by a fixed number every year. And for part A of the question, we're asked for their salary in year 10. So this is a snapshot, because all we care about is that specific year, which means for part A, we're going to be using the formula for sequence. Now, the formula for an arithmetic sequence is U sub n is equal to U sub 1 plus n minus 1 times d. And here we know that U sub 1 is 70,000 because that's the starting salary in year 1. We know that the common difference here is 3,500 because that's the increase every year. And we know that n is equal to 10 because we're interested in year 10. So therefore, we can now substitute all these values in. And we get U sub 10 is equal to 70,000 plus 10 minus 1 times 3,500, which means the salary in year 10 is going to be $101,500. Now, part B is asking how much total income will they have earned over their first 10 years with the company. So this here is not looking for a snapshot. It's looking for the total, which is the accumulation. So therefore, we're going to be using the arithmetic series formula. And that is S sub n is equal to n divided by 2 times U sub 1 plus U sub n. And here we know that n is equal to 10. And we know that our U sub 1 is 70,000. And U sub 10 is the number that we just calculated, which is 101,500. So now we can substitute these numbers in and we get S sub 10 is equal to 10 over 2 times 70,000 plus 101,500. And this gives us a total value of $857,500. So this is how much he has earned in total over the first 10 years with the company. Now let's take a look at our next example. Here we have a ball that is dropped from initial height of 16 meters. And each time it strikes the ground, it rebounds to a height that is exactly 60% of its previous height. We're asked to find the total vertical distance traveled by the ball before it finally comes to rest. So because the rebound is exactly 60% of its previous height, this is geometric, not arithmetic. So we're going to be using our geometric formulas. And because they're asking for the total distance traveled, that tells us that we're looking for a series and not a sequence. So now let's go ahead and draw a quick diagram to illustrate what's actually happening here. So the ball starts at a height of 16 meters, which means when we first drop it, it's going to go down by 16 meters. And once it touches the ground, it's going to bounce back up. But this time, it's only going to go up to 60% of its original height. So that means this is going to be 16 meters times 0.6. But then the ball is going to drop down again, and it's going to travel that exact same distance. And once it touches the ground, it's going to bounce back up to 60% of the previous height. So this is going to be 16 times 0.6 squared. And then same thing, it's going to drop back down to the ground, traveling the same distance, and then it's going to keep doing that. And this is going to go on forever until the ball stops. So here we're actually dealing with an infinite geometric series. And with the exception of that very first drop, we can see that every other distance, there is an upward travel and a downward travel of the exact same distance. So we can actually split this question up into two parts. The first part is the downward distance, and that is going to be 16 plus 16 times 0.6 plus 16 times 0.6 squared plus ... And now the upward distance is going to be missing that 16 in the beginning. It starts off as 16 times 0.6 plus 16 times 0.6 squared plus 16 times 0.6 to the power of 3, and so on. So this means to calculate the downward distance, this is going to be s sub infinity is equal to our first term, which is 16, over 1 minus r, and r here is 0.6. And then the upward distance is going to be s sub infinity is equal to the first term, which is 16 times 0.6, so that'll be 9.6, divided by 1 minus 0.6. So therefore, the total distance is just going to be the two of them added together. So total distance is equal to 16 over 1 minus 0.6 plus 9.6 over 1 minus 0.6. And this evaluates to a total of 64 meters. And now for our last example, we have an auditorium that is designed with an expanding semicircular seating arrangement. We're told that the first row of seats has 22 seats, the next row has 25, and then the row after that has 28. So now if the entire theater has a maximum capacity of 855 seats, we're asked to find the total number of rows in the auditorium. So first of all, we can see that the number of seats increases by a fixed number each row, which means here this is arithmetic. And we're told that the maximum capacity is 855. So that is the total number of seats. So here we're dealing with a series and not a sequence, which means we're going to need to use the formula for an arithmetic series. Now we have two versions of that. The first one uses the first term and the last term. But since we don't have the last term here, we're going to be using the other version, which says s sub n is equal to n divided by 2 times 2 times u sub 1 plus n minus 1 times d. Now our values here are u sub 1 is equal to 22. We know that the common difference is 3. And we know that s sub n is equal to 855. And n is what we're trying to solve for. So substituting in those values, we get 855 is equal to n over 2 times 2 times 22 plus n minus 1 times 3. Multiplying both sides by 2 is going to give us 1710 is equal to n times 44 plus 3n minus 3. Now, if we expand out the right side and move everything over to one side, we get 0 is equal to 3n squared plus 41n minus 1710. Now, you can either use the quadratic formula to solve this, or you can factor this. And it doesn't matter which way you do it. But if you were to factor this, you should get this is equal to 3n plus 95 times n minus 18, which means we get n is equal to negative 95 over 3, or n is equal to 18. But n here represents the number of rows within this auditorium, and you can't have a negative number of rows, which means this answer here is invalid. So therefore, we just have one solution, which means we have a total of 18 rows within the auditorium. And now let's do a quick recap of what we covered in this video. We learned the two questions that we need to ask ourselves in order to know which formula to use. The first one is to look for phrases that either says add, subtract a fixed amount, or something like percentages, fractions, or factors. Adding and subtracting a fixed amount signals arithmetic math, while percentages, fractions, or factors signal geometric math. And the second question we ask ourselves is it isolated snapshot, or is it the total? If it's a snapshot talking about a particular row or a particular year, then that is going to be a sequence, which means we use the formula for u sub n. But if we're talking about a cumulative total, then we're going to be using the series formula for s sub n. And lastly, we always need to make sure that everything makes physical sense. So it's always good to sketch out physical path for real-world scenarios like bouncing objects to ensure you don't miss both the upward and downward motion or negative solutions that don't make sense in the real world. And now it is your turn to give this a try. Can you find the solution to the problem on the screen here? Make sure to leave your answer in the comments below and let us know what other sequences and series topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.